Hello, good evening. Welcome to the last and final session of the KubeCon. All right, so, how many of you do not know about the meta controller by now? Everyone knows. Oh, there's two people who do not know. I thought I'll be the first one to talk about it at KubeCon, and every session that I went to had some mention about it. So everyone seems to know what about it. I was going to explain it in great detail, so I'll try to shrink that because the Vitess operator is also built using the meta controller. Anywho, so my name is Sugu. I started working on the Vitess project 8 years ago in 2010 when we were at YouTube. Our MySQL databases were falling apart day and night, and things were completely out of control. Myself and my colleague Mike, we said, this is not going to work. So we took ourselves out of all these day-to-day firefighting and said, let's think about what we can do to leap ahead of all these problems that we are facing. And pretty much that's how Vitess was born. We thought this project is going to take about 6 to 12 months. So 8 years now, and we are not done at all. So much so for how good we are at estimating. So the reality is actually we launched Vitess about a year after we started the project, but it was so cool that feature requests just started pouring in, and we just were busy adding more and more, and it kind of organically grew into what it became today. So I'm going to start off with, and it has also evolved. There are some features that we deprecated, some features that we added, but at this point, it solves 3 main problems. I don't know how many of you were at the keynote. Anywho, so I'll summarize them here for you. It solves scalability problems with your database. It helps you move your database to the cloud, and it makes DBAs very happy. So those are the 3 things that it does. These 3 things are actually pretty related because moving to the cloud makes DBAs very unhappy. So this helps you keep your DBAs happy while you move to the cloud. So what is, before I jump into the thing, the Vitess is, one sentence description of Vitess is, it is a middleware for databases, currently mainly MySQL, that helps you manage and scale it through sharding indefinitely. So that's our one sentence description of Vitess is. So it sits between the application and your database and completely takes over your database, and then you can, after that, scale that forever. Here's the architecture. Since we have only about 25 minutes, I will try to finish this in about 15 minutes or so, another 5 minutes for demo, and leave enough time for Q&A. So this is basically how Vitess works, achieves whatever I said it does, is on the left of the green line is your application. It was probably previously pointing to some MySQL instances. Now it points to this thing called the VTGate, which is a Vitess component. A VTGate speaks MySQL protocol. So as far as the application is concerned, it's still talking to the same MySQL it was talking to previously. But once the query reaches VTGate, a number of things happen. All these components, VTGate and VTtablet, they all have an SQL parser, and they take a look at your query to decide what to do with it. And they make different decisions depending on which stage it is in. So when it comes to VTGate, its job is to figure out where to send the query. So it parses your query, looks at the from clause. It says, from T, where is T? Oh, T is in the following database, or key space. This is what we like to call it, because in Vitess, we differentiate a database from a key space because a key space can be sharded, whereas a database is a single physical MySQL instance. So it figures out the key space. Oh, it needs to go to that key space. And it says, oh, that key space is sharded, which means that I have to figure out which shard the row lives in. So let me go look at the where clause. Oh, where clause says ID equal to 5. Oh, which means ID equal to 5. 5 performs the magic and figures out, oh, it is in that shard, and sends the query there. So when it sends a query, the query reaches one of the VT tablets. So as you can see, there are 3 types of VT tablets. There is a master, there is a replica, and there are RD only, or what you call as big data replicas. So that decision is also made at the VTGate level, where it decides what kind of query are you running. Are you running an update? Are you running a read? Did you ask for a dirty read? So depending on that, it decides whether the query should go to a master database, to a replica, or are you running a MapReduce style OLAP query. In that case, it sends it to this replica. So the differentiation between a regular replica and a big data replica is a separation of workload, because you're allowed to abuse a big data replica without affecting live production traffic. So that's the whole idea of this separation. So it goes to the VT tablet, and VT tablet says, now let's see what we can do with your query. It doesn't directly give it to MySQL. It again parses it and breaks it up and decides what can I do with this query. It may do a number of things, and I'll cover what they are. One example is it may add a limit clause saying that this query does not have a limit clause. What if it decides to scan the entire table, right? What if your where clause is not very good and it scans the entire table? So it adds a limit clause just for protection. And if that limit is exceeded, it's going to return an error instead of returning results, saying, hey, you're trying to fetch too many rows, so that's not allowed. Mainly for OLTP loads. Obviously, if you're in the OLAP load, you can do a full table scan, no problem. And once the VT tablet has modified your query to make it safe, it gives it to MySQL. And MySQL executes the query, returns the results, and the results are returned back to VTGate. So VTGate, before sending the query to VT tablet, might have been a query with no where clause. In that case, VTGate might have sent the query to all shards. If that was the case, VTGate collects all those results, puts them together, and sends them back to the app server. So in reality, VTGate is designed to evolve into a full multi-shard database engine over time. It is about 90% of the way there right now. There are a few parts still missing. But it was written mainly to address most common workloads. So if your application, the workloads that it doesn't address are things like where you shouldn't be doing that query, where you are maybe scanning a whole table there and whole table there, getting all the results together and sorting them or something. If you're doing crazy stuff like that, VTGate says, sorry, can't do. You probably need to be pulling that data in a different form anyway. And how do all these things put together is, how does VTGate know where the VT tablets live, and et cetera? The way it happens is when a VT tablet comes up, it registers itself to the red thing called the log server. The log server can be Zookeeper, etcd, or Console, and in Google, it is Chubby. At YouTube, it's Chubby. So, and I'll go into the history of why we can support these many log servers. So VT tablet registers itself to the log server, and a VTGate, when it comes up new, it goes, looks at the log server, tell me about all the VT tablets, and then it gets all the information and connect to it. But that's not the only way VTGate works with the VT tablet. As soon as it connects to a VT tablet, it establishes a health check feedback from it. Then it uses that health check to make better decisions about which VT tablet to send queries to. For example, a replica could be lagging. What if a replica is lagging way behind? We can tell VT tablet, if a replica is lagging beyond 30 seconds, don't send queries to it. So you can specify rules like that, which VTGate receives directly from VT tablet. Another important one is when there is a reparent. When a master goes down and a new master comes up, that communication is also sent by the VT tablet saying that, hey, I'm the new master now, stop sending traffic to the old one. So that helps the system react immediately when there is a reparent event. In most cases, zero downtime. And I'll explain how, because when that happens, VTGate, when it detects that a reparent is happening, VTGate just holds on to the queries, just waits for the new master to come up, and as soon as it comes up, it just sends them all to it. And finally, VTCTLD on the top left is the dashboard, which is used to take a look at what's happening in the topology. You can also run a few workflow commands through it. All right. So VT tablet is what I would describe as the component that is most responsible for making DBAs happy. As a matter of fact, we spent about 4 years mostly working on VT tablet. The first 2010 to about 2014 or so, it was mostly just VT tablet. And how did we build features into VT tablet? There is an outage, somebody gets woken up, and they complain. They say, hey, I got woken up for this. Why did this happen? And say, first answer is always, it can happen. No. You tell, can we get to the root cause and find out why it happened? And is there a way to prevent this from happening? So over 4 years, we just kept on adding things. Whenever there was an outage, either an outage or it may not be an outage. It may just be frequent noisy pages, right? If a page is noisy, SREs just hate it. They say, this page is noisy, I need this removed, I don't care what you're going to do. But it's very hard to do. No, I want it removed because I only want to be notified when there is a real problem. So all those things, features, we coded into VT tablet. As a matter of fact, now YouTube runs tens of thousands of nodes. One person goes on call, and the system is really, really quiet these days. Very, very high QPS. I'm not allowed to talk about how much QPS YouTube does. And now I'm outside YouTube. All right, so what are those features? The first feature that we did was connection pool. The connection pool gives you 2 important things. One is if there is something like a reparent event, and there are tens of thousands of clients connected to the old master, they all will instantly connect to the new master, and that usually means they will destroy the next MySQL instance, guaranteed. And this used to happen so often that we said, okay, we are going to have a connection pool, and when a reparent happens, this connection pool will be primed, but everybody else has to go through this pool. So that's protection number 1. Protection number 2 is if there is a sudden spike, and you send all the queries to MySQL, that also is something that MySQL does not particularly enjoy. And when that happens, this connection pool throttles the traffic to MySQL and making sure that it's running at maximum throughput. So essentially, by reducing how many queries you send to MySQL, you actually increase its throughput. So that's another thing that this pool provides. Hot row protection is another very, very common reason for things falling apart. The particular instance that I remember is there was a user who had about 250,000 videos or so, and they got featured on the front page of the YouTube index page. So every time somebody hit the front page of YouTube, 250,000 videos were fetched from the database. So imagine at whatever thousands of QPS that page was getting hit at. So that quickly took down our database. So this hot row protection, what it does is, if 2 identical queries hit the database, it will send only 1, or not 2, n. So if n identical queries come in, only 1 query executes. And once that query executes, the results are shared with all n. So after this, we have stopped yelling at our developers. And at the same time, we are also fulfilling all the queries, which is pretty awesome. But we don't. The other thing that it does is the damage control. Damage control is if your query runs for too long, it'll kill it. So the reason why this feature is loved is because it punishes the bad behavior, the person who wrote the bad query. Otherwise, I write bad query, it goes down and starts occupying all the resources and brings down the database. Everybody pays for it. Now, if I write bad query, my query gets killed, and I get the error. So I need to go fix my query before things can run again for me. So these are just some of the highlights. There's actually a whole bunch of features. And so these are often when people start adopting Vitess, they come in because they want to shard their database and stuff, but they get more excited about these features when they come in because these are things that they faced along the way before they reached capacity and said, oh, even with this, I can just buy some more headroom. In fact, Slack, that's using Vitess, they are in the process of migration. They like these features so much that they actually customized a VT tablet. Actually, you can use it yourself as a pure MySQL proxy that just sits in front of MySQL that performs all these functions for you. So that's a data point. So cloud. How did Vitess, why is Vitess cloud native? There is some history. Vitess was originally not built for the cloud. 2010, YouTube, we were on our own data centers. And this was a bare metal product, as you would call it. But in 2013 or so, Snowden happened. And Google said, all data should be inside Google. So we said, OK, we'll migrate all the data. And how do you test whether an application can run in the cloud? The same way you test whether something can float. You just put it in the water and see what happens. So we put Vitess in the water. It sank to the bottom. But then we had to make it run. And we had an even bigger challenge because Vitess was open sourced. And I don't know how many of you are from Google or have written code within Google. If you write code within Google, you cannot outsource it. Because the Google ecosystem is so unique and all proprietary stuff, it just cannot be brought out into the open source. And same is true if you have written something into the open source. How do you change it to? You can change it to use Google, but then you have to abandon the open source. So we had a challenge, and we had some very heated conversations. And finally, we said, OK, we'll bite the bullet. We will keep this open source, and we will write interfaces for each and every one of these challenges. So we wrote interfaces for Chubby, interfaces for Stubby. We wrote interfaces for all these things that are internal to Google. And that is the reason, because we were initially built on Zookeeper, we built an interface for Chubby. Somebody said, can you support etcd? Oh, no problem. Somebody sat down, overnight, we had an etcd adapter. And then somebody asked for console, and overnight, we had a console adapter. So, and same way, like we were on Bison RPC before. Because we wrote that interface for Stubby, gRPC came, and overnight, we were on gRPC. So those adapters have left. And finally, when Kubernetes came out, we were overnight ready for Kubernetes. Actually, we were the first ones to announce to be Kubernetes cloud ready when Kubernetes came out. This was, I believe it was 2014 or 15. No, whenever. You can there's a blog post that you can go find out about. So cloud ready is not just these features that you see on the slide here. It's actually a different way of thinking, and it affects storage differently. One thing is cloud likes smaller instances, and data tends to be all big, like terabyte size database is usually where you start talking about things, right? So one problem is shrinking that database. The other problem is databases don't like to be bounced. They are very, very unhappy. Even though they are supposed to be bounce-proof, they don't enjoy that kind of experience. So we had to deal with that. And then the other thing happened is if you shrink these databases small, and now suddenly you have like 1,000 of these instances, you cannot use the log server like you used before. So one of the experiences we had was you used to take down the log server because we used to spam it with calls. So you have to reduce those calls. And you cannot use the log server for everything also, because if there is a reparent event and you want to communicate that to VTGates, you cannot go through the log server because it has delays. So all these things, there are very subtle things that you have to kind of learn when you move to the cloud about how to balance resources, how to assume the general assumption of the life cycle of software is very different. So all those things have to be taken into account. And these are things that, so this is the reason why even just being compatible with the cloud API is not always sufficient. to say that you're cloud native. You actually have to run there, and you have to get the mileage where you actually go through these issues that you run into and iron them out. And YouTube, Vitess has been running in Borg since 2013 or so, so it has about 4 or 5 years of very high QPS, good mileage. And because of that, people are able to run Vitess in Kubernetes in production. I don't know if you remember what I said at the keynote. JD.com runs thousands of Vitess nodes, and they've been doing it for almost a year now. And they are migrating their entire fleet. They are about 25% of the way right now. All right, scalability. Scalability, the biggest feature is obviously the biggest feature of Vitess is that it hides the pains of scalability away from you by hiding all the sharding logic. So you, as an application, if you're talking to an unsharded database or a single database, you can deploy Vitess on top and point the application to Vitess, and it continues to work like before. But now you have the opportunity to reshard, and when you do that, you don't have to rewrite all of the application. There will be some impact because distributing data has its cost. And sometimes not all queries will work the same way, so some queries have to be rewritten, some queries may not work at all. But the impact is highly minimized. I would say 90 to 95% of your application should run mostly unmodified. And Vitess allows you to control how sharding works. There's actually about 2 or 3 different ways you can control sharding, which actually has proven that any type of workload where sharding is needed, it can satisfy. I don't have much time to go into the details, but there are talks where I've talked about this one. There are cross-shard indexes. So what we did was, when we decided to shard, to provide sharding, we didn't go and use the NoSQL approach. We said, let's look at how a database works and extend those concepts into the sharding. So we have primary keys, primary indexes, secondary indexes. We have a schema, which we call a V-schema. We have the loose notion of a foreign key, which is very useful to keep rows together within the same shard. We have sequences. So essentially, for you as application, you think that you're connected to a giant database. So this is kind of the roadmap. Even though some inefficient queries are rejected today by Vitess, we think that we should make them work because then users can decide whether they want to rewrite it instead of us outright saying, no, you can't use this query. V-schema-based resharding, the way I would call it, the better name for this is the regret feature, which means that I decide to shard my system one way, and I realize that it was the biggest mistake. Now I say I want to rekey, I want to shard by another column instead. And this feature will let you reshard your entire system using another column, again, with no change to your application. And another one is there is actually synergy between Paxos and 2PC. Because they are both two-phase protocols, and there are ways to actually shadow one with the other. So we have some ideas about how to do it, and that is something that we actually want to do. I have written some blog posts about hinting at how this can be done. So if you're curious about these things, you can read up or send me email. I can share about what I have in mind. All right, so with this, I'm going to jump to a demo. Since most of you know about this thing called the Meta Controller, this is the website for it. And in the Meta Controller, there is a Vitess operator that you can see. And any of you need a 2-minute primer on how the Meta Controller works, or should I assume you all know? All right, so yay, I get to talk about the Meta Controller. So the meta controller is I guess, a job or a deployment. And what it does is a binary that sits. And it actually has the functionality that is most commonly performed by most controllers. But it lets you choose which you want to do and how you want to do it. So the way to install a meta controller is you go to the page and there is the line here that says kubectl apply manifest, and then it's installed. And then once you've installed it, the way it works is it has two parts. On one part, you define all your CRDs, which is these are all my custom resources, and then you say these are how they are composed, and these are the hooks that you have to call when they get invoked. So it's very simple. Let me give you an example. Okay, I go to the Vitess one. So here you go. So this is the first part of the controller, which says here is a CRD for, and you can see that the CRDs are defined as things that are Vitess concepts, which is like what is a key space, there is a cell, there is a cluster. So these are elements that are meaningful in the Vitess world that Kubernetes knows nothing about. So these CRDs are defined here. And then it says here are how they are composed. Here's a composite controller for, in this case, it is a cluster. So a cluster is composed, and the way you, when I ask you to bring up a cluster, this is the hook that you have to run. And when I ask you to bring up a cell or change a cell, this is the hook that you have to run. So this part gives you the CRDs and defines which hooks to run. And then the hooks are defined in under here. As you can see, there was a cell hook, and if you invoke the cell hook, it calls your sync cell hook. When you apply a cell, it calls the sync cell hook. And this has all the logic that is needed to deploy a cell. It just generates essentially a YAML for you, which the meta controller executes. So it's very simple. Otherwise, writing a controller was considered very heavyweight, and you had to write code, and writing code is painful. This one, you can write a meta controller either using JavaScript or JSONnet, or there are a couple of other languages that Anthony supports. And since Anthony is a Vitess alumni, he decided that he should give Vitess as an example in his meta controller, which we feel very honored about. Okay, so I am going to, I lost my connection here. The way to launch a meta controller is very simple. Just issue this command. That's it. So I just deployed Vitess. And let me show you the YAML that I ran. It takes a while to come up. So while it comes up, I'll show you the YAML that I ran. That is myvitess.yaml. So there's a Vitess cluster. Inside the cluster, I want some. There are cells. There is a global cell. Global cell is actually not a physical cell. It's actually the cell that consolidates everything. And in that, I want to run my daemon, my VTCTLD, which is my dashboard. And there are local cells, which are where all the real instances run. There is only one zone here, which is zone 1. And then there are key spaces, which are those databases. And each key space, there is a name. And is it sharded? If it is sharded, what are the shard ranges? And which cells do those key spaces run? So these are all things that are very natural for somebody who is familiar with Vitess. And you specify this. And once you specify this, you go to your Oh, I should show you how a meta controller deploys itself on Kubernetes. So if you go to the meta controller namespace, you can see that in config maps, you see the Vitess operator hooks. So all that code that you saw under hooks just is deployed here as just config data. And the meta controller uses calls into these as needed. There should also be a deployment for the meta controller running. Oops. Unknown server error. There you go. Woo! But this is the default namespace. Let's look at the meta controller. There you go. There's the Vitess operator running and the meta controller running. So the controller part runs in a different namespace so that it doesn't clutter up your namespace itself. And if you go to the default namespace, which is where things are, you will now see all the components that I showed in the architecture diagram. Let's see. Was it pods? Yeah. Actually, it should be in, where was it? Deployments, yeah. Oh, deployments is only, yeah. So in pods, you can see there's an etcd cluster, the log server. There are VT tablets, which are actually running the MySQLs. And there's a VTCTLD, which is the dashboard, and there is a VT tablet. So if I go to services, services is where I meant to go. This has a better high-level view of. So every box that you saw in the original architecture diagram, you can see it here. And then I did VTCTLD. Let's hope it's come up now. And this is the Vitess dashboard. I think it's coming up. Yes. And this says, I brought up key spaces. It has 2 shards. If you go inside each shard, you can see the tablets that are present. You can look at, and you have various things that you play with inside Vitess. So that concludes my talk. Let me know if you have questions. Oh, thank you.
All right, so this is probably going to be a common question. If you have an existing MySQL database, can you onboard it into Vitess?
6 Sigma database.
No, an existing MySQL database.
Oh, an existing MySQL database. Is it MySQL?
Yeah, or maybe Percona.
Oh, Percona is fine. Yeah.
Yeah,
So Percona is MySQL. When I say MySQL, it's MariaDB, Percona, or regular MySQL, or MySQL 5.6, 5.7, 8.0. So Vitess runs like an application, so it doesn't go into the guts of MySQL. It drives it mostly like a traditional database. As a matter of fact, we think we can easily port it to Postgres. We just don't have enough time. We have our hands full handling MySQL users. An existing schema, all you have to do is, not everybody has followed my advice. I don't know why. I tell them, if you're running MySQL, just deploy Vitess on top and repoint your application. And then you can reshard it underneath. A few people did that. But most people, like Slack, for example, they said, oh, this is a great opportunity for us to reshard. So they actually deployed a resharded Vitess on the side and migrated the data into their reshard. And that's how they are migrating. They are migrating into a new sharded scheme than what they had before. And some people, for whatever reason, are just copying data into new MySQL, new Vitess instances, and without touching what they are serving. So all strategies have been used. At YouTube, we just deployed Vitess on top of existing MySQL, because that allows us to go back and forth, right? You go send some traffic to Vitess. If something breaks, you fall back, right? So it gives us that option. So yeah, Does that answer your question?
Yes, thank you. One quick question. Do you use the MySQL upstream code for query parsing, or do you have to kind of follow their updates when something new happens?
Oh, query parsing, we have our own parser. And HubSpot did a good job. They had I think they had terabytes of query logs. They just dumped it on Vitess and saw what happened. Obviously, many of the queries failed, but they went through and fixed most of them. So it's still tries to be, the way the parser works is it tries to be agnostic. When there's a function call, for example, it doesn't validate that that's a valid function call. So it relies on mostly pass-through. So if the query is structurally correct, it just passes it through to MySQL. And if there is something wrong with the query beyond the structure, then MySQL returns the error.
Thank you.
Any other question? Yeah.
How secure is Vitess against data losses?
Oh, yes. Excellent question. Yeah, very good question. So the question is how safe is Vitess against data loss? So running in the cloud is the scariest thing for people. Especially they can't accept that instances can be ephemeral. So how did we make Vitess robust against data loss? MySQL has this feature called semi-sync replication. That gives you a guarantee that before a commit is completed, the data is replicated and sent to at least one other replica. And so master will not acknowledge your commit actually will not even commit your data until at least one other replica has received it. If it has received it, then it commits and then it returns. And I don't think this is not mission critical financial enterprise grade robustness. But at YouTube, we have run this for many years and we haven't had an incident because of this. And this is also very convenient because if the master fails, there is always a replica that has the latest data, so we can quickly identify which one it is and do a very, very fast failover. So that has, many of the users that came, you'd be surprising, many of the users that came to use Vitess, big reputable companies, were not even running with this semi-sync thing. When they realize, oh, wow, you get this great resilience with semi-sync, now most of them actually, with our recommendation, are running with that mode. Does that answer your question? Yes. Cool, yeah. Yes?
Hello. What's happening when a new MySQL connection appears? So, I mean, where is authentication processing? Is it Vitess or VTGate intercepting authentication requests, or it's proxying it to real MySQL instances?
Good, yeah, good. So because we use connection pools, you cannot authenticate what the user is connecting because the user, there may be, in a company, there may be thousands of users, right? Or there may be only 100 users. So but the connection pool that Vitess uses connects to MySQL with a specific username. So the way we work authentication is it's all done at the Vitess level using, like if it's gRPC, you use certificate names, TLS certificate names to authenticate that you can call. If it is MySQL, then there's the MySQL authentication protocol that is implemented by Vitess. And we often tie it into the LDAP system. There's at least one integration with the LDAP system. So that authentication happens, and that authentication goes all the way to VT tablet. And there is actually a way to configure ACLs for which tables you can read, which tables you can write to, that is checked by Vitess and accepted or rejected based on that. So basically, we do not rely on MySQL's authorization or authentication. Vitess has its own.
Wow.
Oh. Yes.
So could you maybe quickly compare Vitess to Spanner and Cloud Spanner? Because from description, seems like the two systems are trying to solve the similar problem, only Spanner without MySQL compatibility.
Yes, there is actually feature parity between the two. The big differences are Spanner and Cloud Spanner are very, very consistency driven, consistency and durability driven, which means that with Spanner you can get cross-shard MVCC reads, which means that you can say I want a distributed, consistent view of the data. Spanner will give you that. Whereas Vitess that drives individual databases doesn't inherently support that. The other one that Spanner is good at is with durability. When I talked about semi-sync, it is one other replica. Most likely it could be the replica that's sitting on the next rack, or maybe even usually within the rack we don't allow replicas to live on the same rack as their master, so it'll be a replica on the next rack. Whereas in Spanner, that is extended using Paxos across data centers. Well, of course, cap theorem is there. You do pay the latency price for that round trip.
I'm using it.
Oh, you're using it, yes, yeah. So yeah, it's a super solid system that way. I've seen it inside Google. It's pretty.
So do I understand correctly that with Vitess, there is no way to guarantee transaction between two, how is it called?
So Vitess gives you
shards?
2PC completion, which means that it gives you atomic transactions. What it doesn't give you is isolated views.
Got it.
Isolation in views, yeah. Which is, the way we call it is, you don't get repeatable read consistency, you get committed read consistency, which is when you read, whatever is committed is what you read, yeah.
Thanks.
Can Vitess be used with managed database solutions like Cloud SQL?
Yes, we want to. So there is an issue out there that we have to run. We just did a proof of concept with RDS, not because of any preference, it's because somebody was asking for it. And we got Vitess to run against RDS. And since Cloud SQL is the same type of deployment on Google, we believe that it should be pretty easy to get that running. So at this point, we only have a proof of concept.
Okay. So it's on the roadmap probably, but not yet there, or?
Pardon?
It's on the roadmap, but not yet there.
Yes,
or?
yes, definitely on the. So that's something that we may do it as planet scale because people are asking for it as a paid service because they're already paying money to RDS. They say, oh, can we have a combined view of it? So we don't. But anything that is outsourceable, open sourceable, as a matter of fact, actually, the proof of concept says that you can run today against Cloud SQL. We just haven't tried it. Because all you have to do is bring up Vitess in a mode where it says, don't manage MySQL, just route queries to it. So as long as Cloud SQL is compatible in that way, you can route queries to it.
Okay, thank you.
Thank you. All right. Yay. Oh.